We just saw that the sun's energy is created at the core here, where the temperatures are over 10 million kelvins. So just 10, that's not milk, that's 10 mil K. I guess I'll just say 10 million kelvins. So that's what happens at the core. Above that, though, so this is the part we're going to look at next here. So here you have the sun, you have the surface of the sun. We'll be looking at it as different layers. In these upper regions, you have, let's review that again. You have a big ball of hydrogen, and in a cooler region, the hydrogen can exist as just an atom with a proton and electron orbiting around it. But the deeper you go, it's so hot that the atom breaks apart. And the region above the core, it's so hot there that what you have are just free protons and free electrons whizzing around. And it looks something like this here. This is called a plasma. And so the energy, the heat that's created at the core, and there's another particle that's there also, a particle of light. So there are also photons moving around. So I'll draw a photon like this here. Just a little a wave packet of light. And you can see the photon right there. So what's happening is that above the core, energy is created, and with that, so the photons carry this energy. And what's happening is that when they're moving through the core, they're kind of like in a pinball machine, where these particles of light that are carrying so these are the photons, and they're carrying the energy from the nuclear reaction. So they're moving very fast, but they can't move in a straight line. They're actually bouncing back and forth like a ping pong, like a pinball, in the region above the core. So this process where energy above the core, the energy is carried by photons. That's called radiation. So this region here, we call that the radiation zone. So the next layer above the core is called the radiation zone. And the reason why is that energy from the core is carried by photons away from the core. So it's carried by photons, or another word for that is by radiation. But that radiation doesn't move in a straight line. What happens is that because of you can see the picture here, these photons, they can't just move in a straight line. They're actually bouncing back and forth there. And it actually takes thousands of years for them to make their way outwards. But this region, energy is carried by light, so we call that the radiation zone. So above that, let's go back to our composition. So here above the radiation zone, here is cool enough that atoms can exist, where you have a proton at the center and electrons orbiting around that. So once these photons make their way upwards from this, once they get to these cooler regions, then these photons can actually get absorbed by these atoms. And as the photons get absorbed, then the atoms, they gain energy. And I'll just retry that again here. So you have your hydrogen atom over here is cool. So a photon from the bottom comes in, and when the photon is absorbed by the atom, what happens is that that atom gains energy, and the atom becomes hotter, and that atom is able to float upwards. Just because of the very fact that it's hotter. So just above the radiation zone, you have a cooler region where atoms can exist, and those atoms absorb heat, which is what you see here. So the photon comes in, the atom absorbs a photon, and while the photon is absorbed, this atom has excess energy, which means that it's going to be hotter. It'll be moving faster, and because of that, it's going to float upwards towards the surface. And next, we're going to see how this process works. So here's this picture, the simple model here. What happens? So you have a cool gas here, And as that cool gas absorbs heat, then the gas atoms can move faster, and as they do, they expand outwards. And in this case here, they'll make the balloon become bigger. And in a fluid, the general idea works, and we looked at this before in terms of the Earth, and also in terms of Jupiter. As the fluid heats up, it's the same thing. The water molecules, they gain more energies and they can move faster. And as they do, they float upwards towards the surface. But once they reach the surface, they cool down and they fall back down towards the hotter regions, and they get heated up again and are forced to rise, and that cycle repeats. So the same thing happens in the sun. So you can see here, the heat, the energy is created at the core, and that heat first flows outwards and is carried by photons or particles of light in a radiation zone, and they're just bouncing back and forth here. But eventually they reach these upper regions where it's cool enough that atoms can form, and here the atoms carry the heat away in these cycles, or these convection cycles. So this region is called the convection zone. So above the radiation zone, you have another region which is called the convection zone. So in these convection zones, what happens is that it's cooler than the lower regions. So atoms can form. And those atoms heat up, and they convect, and they create convection cells that carry the rest of the energy away. So I'll write it as written on the side there. So the energy that was created from the core is carried outwards now to the surface by convection of hydrogen gases. Or hydrogen atoms. And this picture shows you here how this process actually looks like. So what you're looking at are these columns of convection cells. So what the picture looks like is this. So where the hot gases rise is brighter, and where they're sinking is darker, because they're cooling down and they're falling back down. So wherever it's relatively cool, you'll find that these regions are going to be darker here. And that's what you're seeing here. You have these columns of convection where here, this is a region where the gas is rising. All the bright spots here are regions where the gas is rising, and all these dark these dark regions are where the gas is sinking back inwards. So you can see these bubbles here. So the surface of the sun is bubbling with these columns of convection. And you can see here a picture of the sun where you can clearly see these columns of convection on the surface of the sun. And these columns of convections, there can be as big as Texas. So these columns here, they look like grains, so we call those granules. And these granules can be the size of Texas. Yeah, so you can see Texas right there.